Building bridges has long been a big idea, and many ancient examples still stand today. Recently, Prague residents celebrated the 650th anniversary of the laying of the first stone of their famous Charles Bridge. Named after its founder, the Czech king and Roman Emperor Charles IV, the Charles Bridge was at the heart of the Roman Empire when it was founded in 1357. For almost 300 years, it was the only bridge to connect Prague across the Vltava River. In 1940, the big idea of bridge design had a serious reality check when the Tacoma Narrows Bridge collapsed. The suspension bridge in Washington State, USA, buckled and broke up in high winds. Since then, methods of predicting the impact of wind turbulence on suspension bridges have improved. But there remains an element of guesswork until a bridge is actually completed. Now, a new supercomputer at the University of Nottingham is helping to reduce the element of guesswork. Researchers hope it will help explain the effects that the forces of nature have on man-made structures. The mechanical engineering team at Nottingham University are using 3D computer modelling techniques to assess the danger of wind turbulence.
With the new computer, we can run faster cases. We can run cases where we calculate far more eddies and far more detail of the forces within it. But the other thing we can do is we can look at many different setups. So you might want to look at a bridge design and say, what happens if we change this parameter? What happens if we change another parameter? And we can change that. We can test many different values of that parameter all at the same time to come up with a detailed understanding of what that design is going to look like.
The high-performance computer will allow researchers to perform calculations 100 times faster than is currently possible. This will help engineers develop safer designs for the next generation of suspension bridges. Recently, an agreement was reached in Berlin between the Danish and German authorities to proceed with the construction of the Fehmarn Belt Bridge. The bridge will run 19 kilometres from a point about 2 kilometres west of Rodby in Denmark to Puttgarden on the island of Fehmarn, which is already connected by a bridge to the German mainland. Construction is due to start in 2011 and is expected to be completed in 2018. The single-track railway line will be electrified by the time work on the bridge is completed. A double-track electrified railway line is planned to be made available 7 years after the bridge's opening to traffic. The 4 pillars carrying the bridge will be approximately 280 metres tall. The vertical clearance will be 65 metres, allowing sea traffic to and from the Baltic Sea to go beneath it. The design has tentatively been decided to be a triple-span cable-stayed bridge with 4 road lanes and 2 rail tracks. Costing an estimated €5 billion, the bridge will shorten the rail journey from Hamburg to Copenhagen from nearly 5 hours down to 3.5 hours. According to prominent Danish bridge specialist Professor Niels Gimsing from the University of Technology in Copenhagen, the projected 20-kilometre long Fehmarn Belt link will be among the longest fixed links in Europe, and it will be a very special piece of construction.
The investigations indicate that the most sensible solution will be a bridge crossing over the entire width of the strait. And it will probably be similar to the Øresund Bridge. It means that it will carry both road and railway traffic with the train running on the lower deck and the motorway on the upper deck. And it will be almost 2.5 times as long as the Øresund Bridge, because it has to reach from coast to coast. And also it will need to have higher towers. First of all, there will be 4 towers, and each will be approximately 300 meters high.
The aim of the fixed Fehmarn link is to speed up the integration of Scandinavia and Europe.
And we need more and more direct communication between Copenhagen and Berlin, and for that purpose we need the bridge.
Building bridges through space, whether it's between countries or simply over a local river, will no doubt continue to be a big idea of the future. The big idea of reaching for the sky and constructing monolithic buildings of a grand scale really took off in 20th century New York. Commissioned by US car manufacturer Walter P. Chrysler, the building that bears his name opened its doors on May the 27th, 1930. Chrysler, whose first car made its debut in 1924 at the New York Auto Show, also had his offices in the building. However, the Chrysler building, at 1,048 feet, was able to hold on to its title of the tallest building in the world for only a year. In 1931, the Empire State Building, at 1,250 feet, took on that prestigious mantle. Now, the Empire State Building stands at 1,453 feet and just over 8.5 inches, or 443.2 metres, including its lightning rod. The Empire State Building might have emerged taller, but many people still consider the Chrysler Building as more beautiful and picturesque. Under Tishman Speyer Properties ownership, the stainless steel masterpiece has seen some of its 1930s grandeur expanded into a modern 1.99 million square foot office centre. During the extensive renovations to the Chrysler Building that began in 1998, Tishman Speyer Properties focused on the preservation of classic features, repair and restoration of the landmark facade, and state-of-the-art improvement of the interior systems and mechanics. For many, the Chrysler Centre remains an integral part not only of the New York skyline, but also an internationally recognised symbol of human accomplishment and potential. Assistant Property Manager, Chrysler Centre, Amanda Carpenter, was at hand to speak about what makes the glistening building special.
There's so much that's exciting about the Chrysler Building. It's such a New York icon. I think you'd be hard-pressed to find someone who couldn't recognize and pick the Chrysler Building out of the skyline if they had to. Tishman Speyer Properties has done a great job restoring this landmark. We spent 1.5 years just restoring the mural here in the lobby alone. We've done extensive restoration of the building elevators, which, as you may or may not know, are all landmarks, and each one of them is individually unique.
While it's not the tallest building in London, the new headquarters of an insurance company is certainly the most attention-grabbing addition to the skyscrapers that crowd the city's financial district. The slim glass tower tapers at top and bottom. The circular shape gives office workers maximum access to window space. It's also designed to draw in the wind to act as a natural air conditioner, cutting energy demand by half.
Like an aircraft wing, it's low pressure where the air is moving fast, it's high pressure where it's hitting head on. So there's always air moving through these atria. So they bring light, views, ventilation, they reduce energy, and it's fresher. The
building's commissioners told world-renowned architect Norman Foster that they didn't want him to build them a box. He responded with a form inspired by nature. He prefers a pinecone analogy to the more popular gherkin. With its bright, shining exterior and innovative shape, the 40-storey gherkin, as it's become known, is an instantly recognisable addition to an already crowded London skyline. The big idea of building skyscrapers would appear to many to be the invention of New York architects. When thinking of tall buildings, the Middle East does not usually come to mind. This is all about to change, as the big idea of skyscrapers has well and truly arrived in the Persian Gulf country of the United Arab Emirates. Burj Dubai, a tower under construction in the UAE, has become the tallest building in the world, measuring 512.1 metres or 1,680 feet. Once completed, Burj Dubai will have consumed 330,000 cubic metres of concrete, 39,000 tonnes of steel and 142,000 square metres of glass, and it will have 56 lifts travelling up to 10 metres per second. As the focus of the big idea of skyscrapers has shifted to become a global affair, the never-ending desire to build beyond the clouds will remain the centre of all architectural achievements of the future. The big idea of planet discovery and the exploration of distant galaxies has taken a new direction in recent times. The James Webb Space Telescope, or JWST, is a large infrared optimised space-based telescope that will be launched early next decade. According to NASA, the JWST will find the first galaxies that formed in the early universe, connecting the Big Bang to our own Milky Way galaxy. The telescope will have a large mirror, 6.5 metres in diameter, with a sun shield the size of a tennis court, and will orbit about 1.5 million kilometres from the Earth. The JWST will peer into the past and image galaxies and clusters of galaxies at a greater distance than ever before. For the first time, scientists will be able to observe the formation of the first stars and galaxies in the universe billions of years ago. A big idea for students and amateur astronomers alike is the Worldwide Telescope, or WWT. WWT is a computer program created by software giant Microsoft. Users are able to pan around outer space and zoom as far into any one area as the data will allow. The Worldwide Telescope is based on rich web applications, bringing together imagery from the best ground and space-based observatories across the world. Images are taken from the Hubble Space Telescope and approximately 10 Earth-bound telescopes. The free service allows seamless panning and zooming around the heavens, with rich image environments stitching together terabytes of high-resolution images of celestial bodies and displaying them in a way that relates to their actual position in the sky. People can freely browse through the solar system, galaxy and beyond, or take advantage of a growing number of guided tours of the sky hosted by astronomers and educators at major universities and planetariums. The universe can be viewed through different wavelengths of light to reveal hidden structures in other parts of the galaxy. Sky Mode is the main feature of the software. It allows users to view high-quality images of outer space with images from dozens of space and Earth-bound telescopes. Each image is placed in the exact same position that it would be expected to be found in the sky. There are over 50 full sky images in bands ranging from radio to gamma. There are also thousands of individual study images of various astronomical objects from space telescopes such as the Hubble Space Telescope, the Spitzer Space Telescope in infrared, the Chandra X-ray Observatory, as well as many other space and ground-based telescopes. Earth Mode allows users to view a 3D model of the Earth, similar to NASA World Wind, Microsoft Virtual Earth, and Google Earth. It is not powered by Virtual Earth, but it does use satellite and map images. It also uses two other free images from NASA. They are Aerial, Hybrid, Streets, NASA Blue Marble, and Earth at Night. NASA Blue Marble and Earth at Night are both a view of the Earth with a resolution to 100,000 feet above sea level. Planets Mode currently allows users to view 3D models of 8 celestial bodies: Venus, Mars, Jupiter, 4 of Jupiter's larger moons, and our own planet's moon. The Panorama Mode allows users to view panoramas, such as several Mars rover panoramas, as well as other gigabit panoramas, such as the ones available for HD view. Recently, the European Southern Observatory at Paranal in Chile has been searching for planets in orbit around distant stars. Scientists have employed a big idea that examines a star's oscillations caused by a close orbiting large planet. Astronomers using a new technique have discovered a much smaller planet closer in size to Earth, orbiting a brown dwarf star about 20,000 light-years from Earth. The icy planet is around 5.5 times the size of Earth. The new planet is the third to be uncovered by the gravitational microlensing technique. A distant star, the source star, when aligned with another closer star, will have its light concentrated by the gravitation of the closer star, the lens star. This gravitational bending of light was predicted by Albert Einstein. The big idea of the gravitational microlensing technique opens the possibility of finding relatively small planets with masses and orbits similar to Earth. In the mid-1950s, the British engineer Sir Christopher Cockerell built a number of ground effect machine test models based on his big idea of using air between the hull of a boat and the water to reduce drag. Sir Christopher's ground effect machine, or hovercraft, came into worldwide use, operating in all types of conditions, from the tropics to the Arctic, in commercial, industrial and military capacities.
The charm of the hovercraft is the amphibious nature, the ability to go anywhere, the noise, the spray, they're just big giants.
40 years on, and after having ferried an estimated 23 million passengers between Portsmouth and the Isle of Wight on Britain's south coast, the Hover Travel Company was the only business in the world to run a daily hovercraft service. When the service began in 1965, the hovercraft was a pioneering invention that promised to revolutionise maritime transport.
The only problem was they do consume the fuel. The existing craft will use a ton of fuel per engine per hour.
But the considerable expense of running and maintaining the craft and the arrival of other innovations like the catamaran made hovercraft travel a highly specialised business.
I think really it's nothing terribly clever. I think we've just used the hovercraft to what it was its best at, which is use the amphibious quality, put it somewhere where there are a lot of people on both sides and people with a bit of money in their pockets. You know, that is the thing, because they're quite expensive things to run.
It's only in specialised environments that the hovercraft is cost effective, like the shallow coastal waters where normal boats cannot navigate. The hovercraft is also used for specialised military uses, like amphibious landings and in oil exploration, where drilling is conducted in shallow waters. A former hovercraft specialist has taken the big idea of hovercraft to the next level and developed the first working flying saucer. Engineer Jeff Hatton has used the Coanda effect, another big idea discovered by Romanian aviation engineer Henry Coanda in 1910 to get his idea off the ground.
I built hovercraft for years, and every time we came to an object we had to go round it, so I always thought we could go over the top. And remembering the old schoolboy trick of blowing over a piece of paper, it lifted. I always thought that, well, maybe if I can generate enough air in the middle, blow it over a surface, it would lift as well. And it does.
The project took years to turn into reality, with a steady growing team of engineers, aeronautical experts, designers and ordinary model builders with a flair for turning ideas and theories into practice. But it wasn't easy, and there were numerous problems to begin with.
The major one was to get sufficient airflow, matching fans and motors, in order to create lift. This was the creation of lift and the shapes of what we're using that made the whole thing happen. From then on, it was the stability in terms of stopping it rotating, because it's single fan, single engine, so there's an awful lot of torque in there that you have to sort out. Then your directional control. And we're improving every month.
There have been several versions of Jeff's flying saucer, and each one has brought new developments and improvements in stability, control and lifting power. The many and varied uses to which the builders think the unmanned air vehicles, or UAV, can be put include inspecting power lines, aerial photography, search and rescue, film production and mine rescue. The list is potentially endless. Eventually it might be possible to build commercial versions which could carry heavy payloads, including passengers.
The most important thing for us to do is to continue to develop the prototype. It needs to be able to lift more, it needs to be able to fly for longer, and it needs to be more robust. And so we're working on that, and we're making progress every month. You must bear in mind it's only 18 months since the first prototype flew untethered in free flight and was controlled. So we're still really at the beginning of this development.
It remains to be seen whether the inventions of Sir Christopher Cockerell and Jeff Hatton survive, as the use of energy becomes the driving force of transport design. But one thing is for certain, these inventions truly are wonderful examples of the big idea. The big idea of a reusable craft for space travel became a reality in the 1980s. After 2 decades of successful missions, a new spacecraft that could be reused was commissioned. The first launch of the Space Shuttle occurred on April 12, 1981, when Columbia, with 2 crew members, astronauts Commander John Young and Commander and pilot Robert Crippen, lifted off from the Kennedy Space Center. Photographers, film and television crew, and journalists swarmed to witness this historic event. About 600,000 spectators from the States and overseas flocked to the coastal area to watch the liftoff. The mission was to accomplish over 140 flight objectives. If it was successful, the shuttle project would be the backbone of the USA space program and bring forward projects such as the International Space Station. It was exactly 7 a.m. Eastern Standard Time, and the liftoff would mark another great milestone in space research and technology. It was also the first US manned space vehicle launched without a previous unmanned test flight of the designed craft. The world held its breath when the shuttle rose on its column of exhaust. The solid rocket boosters contain the solid fuel that provides about 71% of the vehicle's liftoff thrust. They were jettisoned 2 minutes after launch at a height of 36 nautical miles. They deployed parachutes and landed in the ocean to be recovered. Next, Columbia was prepared for MECO, or main engine cutoff. At this point, Columbia was in space and travelling at over 18,000 miles per hour. The external tank, which holds 500,000 gallons of liquid nitrogen and liquid oxygen, was released 8.5 minutes after launch at an altitude of 60 nautical miles. Once in orbit, the machine and crew were put to the test. First test was to open the payload doors. A cooling system is exposed when the doors are opened, and this provides the required cooling of the shuttle's electronics. A following test was conducted to check the flight control systems and control surfaces. The shuttle was one of the earliest craft to use a customised fly-by-wire digital flight control system. While the astronauts were completing their objectives, NASA's Californian Dry Lakes were becoming a hive of activity as nearly 500,000 visitors rumbled into the base to view the spectacular scene of the first ever reusable winged spacecraft guide to touchdown. Back in space, the crew of Columbia prepared for re-entry. The vehicle began re-entry by firing the engines in the opposite direction to the orbital motion for about 3 minutes. The deceleration of the shuttle lowered its orbit down into the atmosphere. This firing was done roughly halfway around the globe from the landing site. The shuttle did a number of arcs and altitude maneuvers to wash off its Mach 26 velocity. Columbia was first sighted by long-range cameras at about 100,000 feet over Anderson Peak in California. The shuttle had decelerated from 26 times the speed of sound to 216 miles per hour. While it completed 2 rollover rehearsals to wash off speed, the shuttle's exterior was subjected to 2,500 degrees Fahrenheit. No test of this stress could be simulated on Earth, and the astronauts were relying on the accuracy of NASA's engineering calculations of this critical phase of the mission. 24 years and 2 disastrous missions later, the big idea of Space Shuttle had taken a new focus. Safety was now the major area of concern. NASA scientists began the countdown in July 2005 for the eventual launch of the first shuttle to return to space in more than 2 years, the Discovery. The 31st mission had to be successful, with so much riding on the outcome. So to eliminate the chance of disaster happening again, NASA's engineers investigated every possible cause of external damage to the shuttle. The result was an upgraded aircraft with a host of new safety features, innovative debris detection systems, and a newly designed external fuel tank. While the big idea of a reusable spacecraft is here to stay, the future of the existing space shuttle remains in doubt after 2010. A replacement fleet will undoubtedly become the next big idea. The big idea of the land speed record is the fastest speed achieved by any wheeled vehicle on land over a course of fixed length. In 1964, at the Bonneville Salt Flats in Utah, 27-year-old Los Angeles speed king Craig Breedlove became the first man to move across the Earth's surface at more than 500 miles per hour. In the process of setting his third world land speed record in his three-wheeled jet car Spirit of America, he also became the first to crash and swim away from it. 526.28 miles per hour, or 846.9 kilometers per hour, was the official two-way average that wiped out his own record of 468.72 miles per hour. On the return run, the vehicle clocked 539.892 miles per hour in the timing traps. What happened next was one of the most hair-raising rides in history, as Breedlove's braking parachute snapped off, leaving him powerless to slow down to conventional braking speed. At more than 300 miles per hour, the racer swerved out of control, spun off the track, sheared off 2 telephone poles, climbed a 4-foot dike and plunged into a canal 6 miles away. When his near-hysterical crew reached the scene, Breedlove reportedly said, "I'm alright baby, what's the speed?" 1 year later, Breedlove returned to the Bonneville Salt Flats with the Spirit of America and set a new benchmark of 600.601 miles per hour, or 966.574 kilometers per hour. Breedlove's record stood for 5 years, until Gary Gaeblitz drove his Blue Flame rocket to break the 1,000 kilometers per hour barrier. The Gaeblitz record run of 630.389 miles per hour, or 1,014.52 kilometers per hour, stood for 13 years, until driver Richard Noble set a new world land speed record of 633.6 miles per hour, or 119.7 kilometers per hour in Nevada, USA in 1983. It wasn't until 1997 that the next big hurdle in land speed records was overcome. Andy Green was a Royal Air Force fighter pilot, and his big idea was to break the sound barrier on land for the first time at the controls of his huge black car, powered by 2 Rolls-Royce engines from a Phantom fighter jet. Green, driving the thrust supercar, smashed his own record of 714 miles an hour, or 1,142 kilometers per hour in Nevada's Black Rock Desert. The thrust roared over the desert track on its first run at 759.33 miles per hour, or 1,214.933 kilometers per hour. That's 1.5% above the speed of sound, according to the official timekeepers from the United States Automobile Club. Some 55 minutes later, Green sped back down the track, reaching a speed of 766.609 miles per hour, 1,226.574 kilometers, or 2% above the speed of sound, for an average two-way speed of 763.035 miles per hour. With another big idea in mind, pilot Andy Green returned to Bonneville Salt Flats in 2006. This time, the land speed record for diesel-powered vehicles was his goal. The JCB Diesel Max was powered by 2 engines, similar to basic tractor engines. Green's first run was made at an average speed of 521.8 kilometers per hour, or 324.248 miles per hour, with the return run averaging 536.43 kilometers per hour, or 333.339 miles per hour, beating the previous record of 378.19 kilometers per hour, or 235 miles per hour, which had stood for more than 30 years. After breaking the record, Green paid tribute to the team.
It's an astonishing car. It's a real huge achievement for the team and for British engineering.
Andy Green has proved that the big idea of land speed records is not just about fuel-guzzling jet engines. He has well and truly set the course for fuel-efficient engines, like diesel, to be serious contenders in the race for speed records. It has long been the big idea of road safety experts to have vehicles that are not controlled by drivers, but rather by computers. Automated driving systems that cruise at a set distance from the car in front, park your car for you, or steer you to the roadside if you fall asleep have long been on the drawing boards of engineers. Now, all this is made possible through Automated Vehicle Guidance, or AVG, a system that can take over driving tasks, ranging from assistance in driving to recognising dangerous situations. The computer in a Fiat car has been programmed to intervene in an emergency. At the push of a button, it will step in and drive the car to the hard shoulder and stop, using an onboard camera to see where it's going. This convoy of vehicles was guided by a computer and magnets embedded into the road surface. Experts say it would be used in special lanes on motorways in the future, where a lot of cars are travelling some distance in the same direction. Furthering the big idea of driverless travel, the US military put a call out to engineers around the country. Bring us a breakthrough robotic vehicle and we'll give you $1 million. It's all part of a grand challenge race of unmanned vehicles, organised by the United States Defence Advanced Research Projects Agency, or DARPA. Officials say they hope to accelerate the development of driverless vehicles that one day could carry supplies for the US military in war zones. Each entry combined robotic technology with powerful computers, satellite navigation and digital sensors. The goal, to make it from the desert town of Barstow, California to the finish line just inside Nevada, without any input or remote control from humans. Plus, the robots were not allowed to hit or crush any animals, support vehicles, or one another on the 200-mile trek. Designers admitted that this is no easy task and emphasised that the length and ruggedness of the racecourse represented nearly unsurmountable hurdles.
You're going to have things like rough roads, you're going to have cliffs on one side and a steep bluff on the other side. You're going to be driving along at 30 miles an hour and you're going to come across just a ditch. And so you have to be able to sense that, slow down, or you're just going to crash right through it.
Though the first event attracted a crowd of several hundred, the dream of unmanned travel still seems some distance away, when most of the vehicles, modified Humvees, pickups and dune buggies, broke down within sight of the starting gate. A year later, the big idea had attracted car manufacturers such as Daimler-Benz, BMW, Volkswagen, Toyota and Nissan, who are currently developing technologies for automated vehicle guidance. 23 robotic vehicles, designed to operate without human guidance, set off just after sunrise to navigate through a desert obstacle course in the US. The modified Humvees, SUVs, pickup trucks and dune buggies had to navigate through hills, valleys, dry lake beds and man-made obstacles over 210 kilometres in order to win the now $2 million prize being offered by the Pentagon. The rugged, twisting course, located 64 kilometres southwest of Las Vegas on the Nevada-California border, was chosen because of its similarity to the place where the US military is currently most active, Iraq. At times, the driverless vehicles also had to cross over railroad tracks and squeeze through narrow passes. The vehicles, kicking up a cloud of dust, left the starting gate every 5 minutes, passed a crowd of about 2,000 spectators and veered off into the Nevada desert. Using global positioning satellites and inertial navigation, the vehicles are programmed to follow a predefined course, disclosed only hours before the race. Radar, lasers and cameras send data to onboard computers that steer the vehicles around obstacles. Organisers limited the race to 10 hours. 6 hours and 48 minutes into the race, the Stanford Racing Team, a team based out of Stanford University, was in the lead, having travelled 193 kilometres. By hosting this event, the US military is aiming to comply with a congressional mandate for a third of US military vehicles to be unmanned by 2015. Now, through research such as these events demand, the big idea of driverless travel is certainly the future for road travel. On October the 14th, 1947, Charles Elwood Chuck Yeager became, at 24, the first pilot to travel faster than sound in level flight and ascent. In the years following World War II, the big idea of breaking the sound barrier was a secret goal of many in the US Air Force. The X-1 rocket-powered aircraft was launched from the belly of a specially modified B-29 bomber, and flight number 50 was the first one where the X-1 recorded supersonic flight at Mach 1.06 or 1,299 kilometers per hour.
This was really a beautiful little airplane. It came along at the right time, and I think we got so tied up with the airplane, and we're so happy that we got the thing supersonic.
50 years after making history by becoming the first person to break the sound barrier, Chuck Yeager, in a reenactment of the flight that was heard around the world, flew a plane at the speed of sound again. Yeager, now an Air Force Brigadier General, was at the controls of a modern fighter instead of the orange X-1 rocket plane, nicknamed Glamorous Glennis after his wife, in which he became the first man to break the sound barrier. This time, he was again accompanied by Bob Hoover, who was his backup in 1947 and who photographed the X-1 hurtling past with characteristic diamond-shaped shockwaves blasting from its 4 rockets. Then an ace combat pilot, Yeager was testing a rocket-powered research plane, the X-1, when he pushed the craft past the sound barrier for the first time. Yeager, who had distinguished himself in World War II, went on to train a generation of NASA astronauts. Yeager epitomised a new breed of crack pilots who risked, and often lost, their lives flying a variety of experimental craft from the 1940s to the 1960s.
I just tell people I'm no hero. I'm just a kid that, you know, it's the right place, the right time.
At precisely 10:34 a.m., the sonic boom reverberated around Edwards Air Force Base in California's Mojave Desert, as the then 74-year-old Yeager piloted an F-15 fighter through the sound barrier at more than 30,000 feet or 10,000 meters above the base. Another difference this time was that the world heard about his flight. In 1947, the Air Force and the National Advisory Committee for Aeronautics, the forerunner of NASA, kept his feat secret until the 15th of June the following year. When he did it the first time in 1947, the sonic boom reverberated from Southern California around the world, opening up a future of supersonic flight and space travel. The speed of sound, Mach 1, is roughly 660 miles per hour, or 1,056 kilometers per hour, at 40,000 feet, or 13,333 meters. And many experts feared his plane would disintegrate when he did what no other aircraft had done before. In a post-flight ceremony that also unveiled a postal stamp commemorating the 50th anniversary of the first supersonic flight, Yeager returned the keys of all the Air Force planes he had flown during his career. However, he kept the keys to the F-15 he had just flown, saying he would use them on an exhibition flight the following weekend. Yeager also thanked the Air Force, saying that, "What I am today, I owe to the Air Force." As part of the festivities commemorating the event, the United States Postal Service unveiled a stamp honouring the X-1's flight.
You have to be dead 10 years before they'll name a stamp after you, but the X-1 is an airplane, so they're honouring the airplane. But if you look in the cockpit real close, you'll see my nose sticking out.
At the time, Yeager, who was 74 years old and still in the cockpit much of the time, said he was finally giving some thought to retiring.
I have never stopped, but having done it for 55 years now, I figure it's interfering with my fishing, so I'm thinking about hanging it up.
Yeager was one of a handful of pilots immortalised in Tom Wolfe's book, The Right Stuff. But unlike John Glenn, Gus Grissom and the others, Yeager did not go to join the exclusive club of America's astronauts. Instead, he chose to stay behind the controls of jet aircraft. Aircraft of the like that helped Charles Elwood Chuck Yeager achieve the big idea of supersonic flight. The big idea to climb the highest mountain in the world had eluded many mountain expeditions before Tenzing Norgay and Edmund Hillary became the first to conquer Mount Everest. Norgay, together with Hillary, on May the 29th, 1953, were the first people to irrefutably set their feet on the summit of the 29,028 foot or 8,848 metre high Mount Everest. When asked who had been the first to step to the summit, Colonel Hunt, the expedition leader, declared they reached it together as a team. Tenzing stressed the unity of such teams and of their achievements. Another interesting aside of this ascent was that all the photos existed of the mountaineers on the top showed only Tenzing. When asked why there were no photos featuring Hillary, Sir Edmund replied, Tenzing did not know how to operate the camera, and the top of Everest was no place to start teaching him how to use it. Hillary and Tenzing remained friends throughout their lives. Tenzing Norgay was undoubtedly the most qualified climber and proved to be the ideal partner for the tall and strong Hillary. In 1952, Norgay had taken part in 2 Swiss expeditions led by Raymond Lambert from the southern Nepalese side, during which he and Lambert reached the then record height of 8,599 metres or 28,215 feet. The second pairing in the 14-man party to attempt the summit, Hillary and Tenzing set off on a cloudless morning after spending a night at high altitude on the south peak of the infamous South Col. Encumbered by clothing and oxygen equipment that modern climbers would deem museum pieces, they inched ahead until they reached the most formidable problem on the final ridge, a 13-metre rock now known as the Hillary Step. Hillary jammed his way up a narrow crack, running vertically up the rock, using all his strength and determination. He then hauled Tenzing up, and they moved on with little left to impede them. At 11:30 AM, they became the first to step onto the summit of the highest mountain on Earth. For years, neither would say who stepped foot on the summit first, but after Tenzing's death, Hillary revealed it was him. By late afternoon, they were back at the South Col camp, and on June the 2nd, word of the conquest was broken by the London Times. The British news won huge media coverage, with the British triumph coinciding with the coronation day of Britain's Queen Elizabeth. During the trek away from Everest, a runner arrived bearing a letter addressed to Sir Edmund Hillary KBE. Hillary was reported to be somewhat peeved that someone had accepted a knighthood from the new Queen on his behalf, while Tenzing received the George Medal from the United Kingdom for his efforts with the expedition. For Hillary, the conquest was a beginning rather than an end. Unlike many climbers, he did not see mountaineering as a spiritual experience. After Everest, Hillary led a number of expeditions. In 1958, he and 4 companions travelled overland in 3 modified tractors to become the first to reach the South Pole by vehicle. In the 1960s, he returned to the Himalaya in search of the elusive Yeti. And in 1975, he led a jet boat expedition to the source of the Ganges. But most of his energy was devoted to helping Nepal's Sherpa people who live in the shadow of Everest. His Himalaya Trust raised around $250,000 annually, and he personally helped build schools, hospitals, bridges, pipelines, and even an airfield. He became inextricably tied to the area, not least because his first wife Louise and daughter Belinda died in a plane crash as they flew to join him at a hospital he was helping to build. Tenzing later became Director of Field Training for the Himalayan Mountaineering Institute in Darjeeling. In 1978, he founded Tenzing Norgay Adventures, a company providing trekking adventures in the Himalaya. For this quiet, unassuming pair from different ends of the globe, the big idea of conquering the highest mountain in the world proved to be just the beginning of a friendship that lasted a lifetime. The big idea of tracked armoured vehicles, or tanks, became a reality during World War I in an effort to break the deadlock of trench warfare. The tank proved the ideal vehicle to cross over barbed wire to reach enemy trenches. Based on agricultural vehicles, the tank's agility over rough terrain, combined with armour to withstand small arms fire and shrapnel from artillery, established it as essential equipment for a modern army. Tanks are designed for frontline action, combining strong attack and defensive capabilities. They are valued for their ability to engage a wide range of ground targets, including enemy tanks and fortifications, as well as their shock value against infantry. In the ongoing race for battlefield supremacy, tanks and armoured tactics have undergone continuous evolution for nearly a century. In the 1970s, the Merkava tank was a result of 10 years of development. Designed to reduce Israel's dependence on foreign manufacturers for her armaments. The main armament was a 105mm cannon. The long cannon's range and accuracy was formidable. During the demonstration, crews scored direct hits on targets at 1,000 metres while bouncing across rough terrain at almost 40 kilometres an hour. The secret was in the ballistic computer and laser rangefinder, which keeps the cannon on target even while the tank is turning. The Merkava's secondary armament were 3 machine guns. All the firepower could be used at close range because of unusually heavy armour plating, which allows the tank to penetrate closer to an enemy than ever before. Only a low, flat turret was needed because the 4-man crew and ammunition were carried deep within the tank for maximum protection. At the Yuma test facility in the otherwise peaceful Arizona desert, the US Army demonstrated the Bradley fighting vehicle in preparation for the First Gulf War. Desert dust can cripple a vehicle, even one as high-tech as this armoured personal carrier. Designed to allow soldiers to fight from the relative safety of the protective armour at high speed, the Bradley was put through extensive dust-proofing tests. The analysis of components, such as air filters, was thorough, as the entire fleet can be brought to a halt if these simple filters fail in dusty conditions. The Bradley was tested along with the Abrams M1 tank, the main battle tank produced in the United States. The M1 is a well-armed, heavily armoured and highly mobile tank designed for modern armoured ground warfare. Notable features of the M1 Abrams include the use of a powerful gas turbine engine, the adoption of sophisticated composite armour and separate ammunition storage in a blowout compartment for crew safety. It is one of the heaviest tanks in service, weighing at close to 70 tonnes. The M1 Abrams entered US service in 1980 and is equipped to withstand a nuclear, biological or chemical attack. Even the crew of the Abrams is protected from extreme heat in the claustrophobic confines of the tank.
It's an example of our microclimate cooling device. And the way it works is the air comes in, goes through a filtration cooling system, and we've got this nylon mesh here. So the air is able to circulate all around and to cool the soldier. It will not become a heat casualty.
Some Abrams are equipped with a missile countermeasure device that can protect against attack from guided missiles. The M1 Abrams is powered by a 1,119 kilowatt Honeywell gas turbine and a 6-speed Allison automatic transmission, giving it a governed top speed of 72 kilometers per hour on paved roads and 48 kilometers per hour cross-country. The tank will operate on diesel fuel, kerosene and any other grade of motor gasoline and jet fuel. The gas turbine propulsion system has proven quite reliable in practice and combat. The big idea of armoured tanks has come a long way since the rudimentary vehicles of World War I, and the tank of the future is guaranteed a place in the armed forces of tomorrow. Building bridges has long been a big idea, and many ancient examples still stand today. Recently, Prague residents celebrated the 650th anniversary of the laying of the first stone of their famous Charles Bridge. Named after its founder, the Czech King and Roman Emperor Charles IV, the Charles Bridge was at the heart of the Roman Empire when it was founded in 1357. For almost 300 years, it was the only bridge to connect Prague across the Vltava River. In 1940, the big idea of bridge design had a serious reality check when the Tacoma Narrows Bridge collapsed. The suspension bridge in Washington State, USA, buckled and broke up in high winds. Since then, methods of predicting the impact of wind turbulence on suspension bridges have improved. But there remains an element of guesswork until a bridge is actually completed. Now, a new supercomputer at the University of Nottingham is helping to reduce the element of guesswork. Researchers hope it will help explain the effects that the forces of nature have on man-made structures. The mechanical engineering team at Nottingham University are using 3D computer modelling techniques to assess the danger of wind turbulence.
With the new computer, we can run faster cases. We can run cases where we calculate far more eddies and far more detail of the forces within it. But the other thing we can do is we can look at many different setups. So you might want to look at a bridge design and say, what happens if we change this parameter? What happens if we change another parameter? And we can change that. We can test many different values of that parameter all at the same time to come up with a detailed understanding of what that design is going to look like.
The high-performance computer will allow researchers to perform calculations 100 times faster than is currently possible. This will help engineers develop safer designs for the next generation of suspension bridges. Recently, an agreement was reached in Berlin between the Danish and German authorities to proceed with the construction of the Fehmarnbelt Bridge. The bridge will run 19 kilometres from a point about 2 kilometres west of Rodby in Denmark. The big idea of reaching for the sky and constructing monolithic buildings of a grand scale really took off in 20th century New York. Commissioned by US car manufacturer Walter P. Chrysler, the building that bears his name opened its doors on May the 27th, 1930. Chrysler, whose first car made its debut in 1924 at the New York Auto Show, also had his offices in the building. However, the Chrysler building, at 1,048 feet, was able to hold on to its title of the tallest building in the world for only a year. In 1931, the Empire State Building, at 1,250 feet, took on that prestigious mantle. Now, the Empire State Building stands at 1,453 feet and just over 8.5 inches, or 443.2 metres, including its lightning rod. The Empire State Building might have emerged taller, but many people still consider the Chrysler Building as more beautiful and picturesque. Under Tishman Speyer Properties ownership, the stainless steel masterpiece has seen some of its 1930s grandeur expanded into a modern 1.99 million square foot office centre. During the extensive renovations to the Chrysler Building that began in 1998, Tishman Speyer Properties focused on the preservation of classic features, repair and restoration of the landmark facade, and state-of-the-art improvement of the interior systems and mechanics. For many, the Chrysler Centre remains an integral part not only of the New York skyline, but also an internationally recognised symbol of human accomplishment and potential. Assistant Property Manager, Chrysler Centre, Amanda Carpenter, was at hand to speak about what makes the glistening building special.
There's so much that's exciting about the Chrysler Building. It's such a New York icon. I think you'd be hard-pressed to find someone who couldn't recognize
of all architectural achievements of the future. The big idea of planet discovery and the exploration of distant galaxies has taken a new direction in recent times. The James Webb Space Telescope, or JWST, is a large infrared optimised space-based telescope that will be launched early next decade. According to NASA, the JWST will find the first galaxies that formed in the early universe, connecting the Big Bang to our own Milky Way galaxy. The telescope will have a large mirror, 6.5 metres in diameter, with a sun shield the size of a tennis court, and will orbit about 1.5 million kilometres from the Earth. The JWST will peer into the past and image galaxies and clusters of galaxies at a greater distance than ever before. For the first time, scientists will be able to observe the formation of the first stars and galaxies in the universe billions of years ago. A big idea for students and amateur astronomers alike is the Worldwide Telescope, or WWT. WWT is a computer program created by software giant Microsoft. Users are able to pan around outer space and zoom as far into any one area as the data will allow. The Worldwide Telescope is based on rich web applications, bringing together imagery from the best ground and space-based observatories across the world. Images are taken from the Hubble Space Telescope and approximately 10 Earth-bound telescopes. The free service allows seamless panning and zooming around the heavens, with rich image environments stitching together terabytes of high-resolution images of celestial bodies and displaying them in a way that relates to their actual position in the sky. People can freely browse through the solar system,
Recognize and pick the Chrysler Building out of the skyline if they had to. Tishman Speyer Properties has done a great job restoring this landmark. We spent 1.5 years just restoring the mural here in the lobby alone. We've done extensive restoration of the building elevators, which, as you may or may not know, are all landmarks, and each one of them is individually unique.
While it's not the tallest building in London, the new headquarters of an insurance company is certainly the most attention-grabbing addition to the skyscrapers that crowd the city's financial district. The slim glass tower tapers at top and bottom. The circular shape gives office workers maximum access to window space. It's also designed to draw in the wind to act as a natural air conditioner, cutting energy demand by half.
Like an aircraft wing, it's low pressure where the air is moving fast, it's high pressure where it's hitting head on. So there's always air moving through these atria. So they bring light, views, ventilation, they reduce energy, and it's fresher.
The building's commissioners told world-renowned architect Norman Foster that they didn't want him to build them a box. He responded with a form inspired by nature. He prefers a pinecone analogy to the more popular gherkin. With its bright, shining exterior and innovative shape, the 40-storey gherkin, as it's become known, is an instantly recognisable addition to an already crowded London skyline. The big idea of building skyscrapers would appear to many to be the invention of New York architects. When thinking of tall buildings, the Middle East does not usually come to mind. This is all about to change, as the big idea of skyscrapers has well and truly arrived in the Persian Gulf country of the United Arab Emirates. Burj Dubai, a tower under construction in the UAE, has become the tallest building in the world, measuring 512.1 metres or 1,680 feet. Once completed, Burj Dubai will have consumed 330,000 cubic metres of concrete, 39,000 tonnes of steel and 142,000 square metres of glass, and it will have 56 lifts travelling up to 10 metres per second. As the focus of the big idea of skyscrapers has shifted to become a global affair, the never-ending desire to build beyond the clouds will remain the centre Denmark to Puttgarden on the island of Fehmarn, which is already connected by a bridge to the German mainland. Construction is due to start in 2011 and is expected to be completed in 2018. The single-track railway line will be electrified by the time work on the bridge is completed. A double-track electrified railway line is planned to be made available 7 years after the bridge's opening to traffic. The 4 pillars carrying the bridge will be approximately 280 metres tall. The vertical clearance will be 65 metres, allowing sea traffic to and from the Baltic Sea to go beneath it. The design has tentatively been decided to be a triple-span cable-stayed bridge with 4 road lanes and 2 rail tracks. Costing an estimated €5 billion, the bridge will shorten the rail journey from Hamburg to Copenhagen from nearly 5 hours down to 3.5 hours. According to prominent Danish bridge specialist Professor Niels Gimsing from the University of Technology in Copenhagen, the projected 20-kilometre long Femern Belt link will be among the longest fixed links in Europe, and it will be a very special piece of construction.
The investigations indicate that the most sensible solution will be a bridge crossing over the entire width of the strait. And it will probably be similar to the Øresund Bridge. It means that it will carry both road and railway traffic with the train running on the lower deck and the motorway on the upper deck. And it will be almost 2.5 times as long as the Øresund Bridge, because it has to reach from coast to coast. And also it will need to have higher towers. First of all, there will be 4 towers, and each will be approximately 300 meters high.
The aim of the fixed Femern link is to speed up the integration of Scandinavia and Europe.
And we need more and more direct communication between Copenhagen and Berlin, and for that purpose we need the bridge.
Building bridges through space, whether it's between countries or simply over a local river, will no doubt continue to be a big idea of the future.